I'd like to introduce you to an innovative approach to an electronic door entry system. Now, if you've ever had a desire to securely lock or unlock your door without the use of a key, this product would be great for you. Now keep in mind, this is a prototype. There may be some exposed wires or other constraints. The development time on the product is approximately 2 weeks, but everything's been done to make sure that the product is close to ship as possible. I would like to talk a little bit about product features. Alright, so just to start off with the ultrasonic sensor, it is the first part of the device that interacts with the user. So at about 6.5 feet, it'll start blinking the yellow LED. And it'll actually activate that LCD. Once that user is within 2.5 feet, the yellow LED stops blinking and becomes solid to let that user know that they're close enough to interact. Now again, on that LCD, once it initiates from the ultrasonic sensor, the LCD will display a welcome on the screen and it'll prompt that user for a passcode. The LCD also can display the numbers the user enters and also displays a notification to the user if they have a success or a failure on their passcode. Next, we have an IR remote on the device. Now, the IR remote has 0 through 9 buttons, and when they're pressed, they appear on the LCD screen. And also has an EQ button that, when pressed, when prompted, will lock the door. Next, we have a passive buzzer here in the middle of our device, which audibly notifies the user of an incorrect or a correct code entry. There are 3 LEDs on the device. We've already talked about the yellow and what it does. The red LED will activate when the user enters a code incorrectly, and the green LED will activate when the user enters the code correctly. Additional features on the device, one would include that we have a timeout feature, so the LCD will shut off after 30 seconds that the user has not interacted with the device. Okay. So that's about it for our features. I'd actually like to do a demonstration of the product. So we talked about what the product does when the user interacts. So I'd first like to start off by what happens when the user enters the code incorrectly. So I'm going to put an incorrect code in here into the device. 5, 4, 3, 2. You have the incorrect audible. The LCD is telling you that you have an incorrect code, and it prompts you to enter a new code. Okay, so that's how it works if you have an incorrect code. I'd also like to show what happens when you put in the code correctly. So let's put in the correct code. The correct code is 4, 3, 2, 1. You get the correct audible. The LCD lets you know that the door is open, and the green LED lights. It also prompts you and lets you know that the door is open and you should lock the door. So we've taken care of all that. I do want to make sure that I lock the door. Press EQ to lock the door. And now we're securely locked again. Alright, so that's how the the product works on the front end. Next, I'd like to show you how everything works on the back end with the stepper motor. Okay, now we'll be testing the operation of the stepper motor from the inside so you can actually see the door lock and unlock. So my wife is unlocking from the outside right now. And there it goes. She got the correct passcode, and I'm giving her the signal to go ahead and lock it. And there it goes, it locks. And we'll actually watch the stepper motor turn. So again, I'm having her unlock it from the outside. And there it goes, so it's turning the lock. We had actually pre-cut and made this lock so it fit that stepper motor perfectly. So it turns. Now again, I'm just going to zoom back over here so you can see when she locks it there, and the stepper motor turns again. And that's the operation of the device from the inside. There's my beautiful wife. Okay, for the last part of this demonstration, I'd actually like to show the door lock and unlock with the door half open here. So let's enter our code in real quick. You can see the door unlocks. There you go. Now we're going to press EQ to go ahead and lock the door. And the door locks. And look, nobody on the other side. It's our stepper motor. All right. Right, everybody, we're going to wrap up this presentation by going through some of the details. So real quick, we've already gone through the features during the video, so I'm not going to cover these here. And these are available in the attached document with the presentation. So all of the features and all the materials here will be included in detail with what they do and what their purpose is. So moving past some of these finer details, again, these are covered in both the presentation videos and the documentation. I do want to touch on a little bit of the diagram. So put this together with the Fritzing program. And this is the breadboard diagram used during setup and testing and everything in between. So if you are interested in how this is set up on the breadboard, feel free to pause here and look at this. I'll also upload the diagram to the project presentation. Also, here's the schematic created for this. So this is also going to be uploaded with the rest of the documentation. Not going to go over it here. If you have any questions, feel free to reach out to me. In the presentation mode, it's a little hard to see since it is kind of in a portrait, so it's probably better if you open this document up separately. And if you're curious how everything connects, I do want to talk. I think I'll spend the most time here at the end talking about the issues and challenges and how those were overcome. So there are more than this, but I think these are the highlights of the entire project. So I wanted to make sure. So this was a learning experience for me. So I had an issue getting the Arduino powered outside of simply that 9-volt DC. I only had the Arduino connected to the computer, and I needed that 9 volts. So anyway, long story short, I did identify that if you use the VIN pin on the Arduino and accept a connection from the power supply from that 9 volt, then I could power that Arduino. So that was great. The second one, the not enough pins on Arduino, that was another tough one. But I did change one of my scope items, which was to use buttons for the code, and I used an IR device. So I went from effectively 4 or 5 buttons, pins, depending on how many buttons I was going to use, to actually just 1, because the IR device just uses power, ground, and 1 for the output. So the stepper motor not powerful enough. This was a frustrating one. Basically, the stepper motor, it's just the one that's shipped with a kit, is only strong enough, and turning a metal lock had its challenges. I won't tell you how many hours I spent on that. Just had to find the sweet spot on the lock. Once I found that, just made sure I locked that in, didn't really touch it or move it too much after that. But if I had another choice, I'd probably buy a stronger stepper next time. Some challenges that were overcome. So basically fitting that motor on the lock, so I actually had to hack an existing lock with my father-in-law. We hacked off the ears and drilled a hole in the top, which really made it look good, or the look of it was good. It functioned well. So I'll include that picture separately as well. The LCD was always on, so just real quick, the code, I just created a timeout function with that. And that was pretty neat to create. Had a lot of fun doing that, so I felt like putting that here. And the passcode arrays, that was a challenge. I mean, anything creating with an array and checking an array and filling an array and checking it again and all that kind of stuff is going to have its challenges. And I just wanted to put in here for everybody that what really helped me create those passcode arrays is checking the serial monitor, having that output to the serial monitor and see what was coming out of those arrays and making sure it worked and functioned properly. So that's where I want to stop there, and really want to thank everybody for sticking around. So I really hope you enjoyed the videos. I had a great time putting this whole project together. Lots of fun, lots of challenges, and in all honesty, this was really fun for me. I hope it was fun for you to watch. And stay tuned for a cool disassembly video. I really it hurt to take the whole thing apart after I put so much time putting it together, but just for you guys, I wanted to take it apart in front of you so you could see it, and it's all in a video for you. So enjoy.